Continuing the numericals on Coulombs law, let's get into the next question, and that is given by we have to find net force on capital Q in each of the following cases. So continuing the same question, let's get into the next figure, and that is, suppose we have a triangle. Here we have a charge Q, here we have minus Q, here we have minus Q, and at the centroid of this triangle we have charge capital Q. We have to find net force on capital Q. The side length of the triangle is given as A. What should be the force on capital Q? Let's find out. One thing is, let's draw the forces on capital Q due to each charge. So the forces can be shown as we have drawn here. The force, this is the force due to the Q at vertex A. This is the force due to the minus Q at vertex B, and this is the force due to minus Q at vertex C. See, this is the total angle is 120 degree and it is bisected here, so we get this angle as 60 degree and this angle is also 60 degree. Now let us find out what is the force applied by each charge. Let us denote them as F1, F2 and F3. The length, the distance between capital Q and small q is A by root 3, or we should write it as 2/3 of root 3 by 2A, which gives you A by root 3. How do we calculate it? That is basic maths of class 10th. Now, finding out the net force, let us first find out the F1. F1 is given by 1 by 4 pi epsilon naught capital Q small q by A by root 3 whole square. So this is simply 3 capital Q small q by 4 pi epsilon naught A square. And if we find out the magnitude F2 and F3, we will get the same value. F2, F3 and F1 have the same magnitude because the charges are same and the separation between the charges is also same. And hence, if we draw the forces again, we can write all the forces as F, F and F. See, the angle between these two forces is 120 degree, so the resultant will be in this direction and equals to F only. So this F is basically the resultant of this F and this F. And hence, from here also we conclude that net force is 2F in this downward direction, where F is 3 times of K capital Q small q by A square, which we saw earlier. See, there is one advice. Whenever I am giving you a question, you should try it first and then only see the solution. For that, you may pause the video and first attempt the question and then see the solution yourself. Getting into the next question, let's see. The charges are small q here, small q here. They are separated by 2a distance, and from perpendicular bisector root 3a, at separation of root 3a we have capital Q here. So this is we have to find net force on capital Q due to the two small q's. See here how can we find the force on capital Q? First we draw these two lines and we find out the separation, the distance. A, this is root 3a, so by Pythagoras theorem this comes out to be 2a and this also comes out to be 2a. If we draw the free body diagram of capital Q, we get one force here in this direction F and again the same force in this direction, means the forces of equal magnitude. The angle between them is equal to 60 degree, so the resultant will be root 3f. Here we are using the same formula, 2a cos theta by 2. The resultant of two vectors whose magnitude is given by a, if the two vectors are equal and the angle between them is theta, then the resultant is simply 2a cos theta by 2. So if you put here theta is equals to 60 degree, we get cos 30, which is equals to root 3 by 2. And this 2 cancels out here and we get root 3f. And simply f can be written as k times of capital Q small q by 2a whole square. So this is what we get as the resultant force on capital Q due to the two small q charges. Similarly, we may have so many different types of geometry and we may be asked about the net force on capital Q. Simply what you have to do is to find force due to each individual charge and then add them.